Okay, students, in this DPP session, it is a cumulative DPP and covers almost all chapters of the physical chemistry. Okay, so this physical chemistry, if you are prepared, if you feel that having any problem and is there any shortcuts to the questions, and when you are doing the chapter wise practice, it may not be that much uh, checking your preparedness. When you go for the cumulative DPP, you are able to identify the chapter or not. If able to identify how much time you are taking, that all will be checked in this and complete when you feel that you wanted to check your ability in the physical chemistry. This is the best DPP. Let's start with the one by one question with the tricks and tips, and as soon as possible we will complete this. Okay. Okay, here is the first question. It is picked up from the thermodynamics. Okay, here it is given as monoatomic. What it is given as monoatomic. Okay, so once we say monoatomic, here everything is interlinked. Monoatomic means CV is equal to 3 by 2 R. Okay, and ideal gas undergoes a process where ratio of P to V is at any instant is equal to 1. Okay, so that means P by V is equal to 1, it is given. Okay, and what is the molar heat capacity of the gas? What we have to find out? Molar heat capacity of the gas. Okay, so that means what we have to find out? CP we have to find out. What we have to find out? CP. Okay. So once it is given monoatomic ideal gas, we know that 3 by 2 R. And CP and CV relation also we have. CP is equal to CV plus R upon 1 minus N. So here problem is with N. For that problem only, we know that PV to the power of N is equal to K. Okay. So here this concept is utilized here. P by V is equal to 1. So we can write it in the numerator. P to the power of V. P into V to the power of minus 1. We can write it as a minus 1. Here minus 1 is equal to N. So that means indirectly we got N value as 1. So you can put over here. Okay. So Cp is equal to, in this formula. In this formula, I am putting Cv place as a 3 by 2 R. Okay. And plus R by 1 minus 1. That is 2. So R by 2. So 3 by 2 R plus R by 2. 3 and half and half. That means 2 R. So answer 2 is correct. Okay. So is that clear? So this type of tricky questions are selected but with easy explanation. Okay. Now let's do the second question. So to reduce the time, already questions are given to you and most of the answers are already explained so that we can complete it in the shortest possible time. At which came we value your time and use the technology to reduce the study time and smart study, we believe. Okay. So 1 mole of ideal gas. So moles are equal to how much? 1 mole at 300 Kelvin in thermal contact. Thermal contact means isothermal with surrounding expands isothermally. Okay. From 1 liter to 2 liter against a constant external pressure. So once it is isothermal, internal energy will be same. So whatever the Q will be there, that is equal to P delta V. And here P is equal to external pressure. Okay. And volume change will be 2 minus 1. So with that you will come to know about the Q. Okay. So in this process, change in entropy of surroundings. Okay. So after substituting here 101.3, that will be liter atmosphere. Here you will get 3 into 1. Okay. 3 atm. So with that, if you substitute here, okay, and 3 into 3 liter atmosphere 101.3. Okay, divided by temperature is given as how much? 300. So on simplifying you will get 1.013. That is not a problem. Okay, this 3 and this 3 will get cancelled. Answer will be 1.013. See here, traps. It is 1.013. It is minus 0.1. Here question is about the surrounding. Okay. So it will be minus 1.013. If it is of the system, it can be plus. Understood? So answer to this question is third option. Next, the orbit and orbital angular momentum of an electron are 3h upon 2 pi. So this is orbit angular momentum. First one is orbit angular momentum. Here what is the formula? nh upon 2 pi. Here when you compare these two, h upon 2 pi, 3h upon 2 pi. That means n value is how much? It is equal to 3. Okay. Root 3 by 2 h upon 2 pi. So this will be L into L plus 2 h upon 2 pi. From this we could come to know L is equal to D. So L is equal to 2. That means it is D. So ultimately the orbital is 3D orbital. What it is given? He wanted to know the nodes in the 3D orbital. There are two types of nodes, are angular nodes and radial nodes. For the angular nodes, formula is n minus L minus 1. It is equal to 1. And planar angular nodes, okay, this is radial nodes, sorry. Radial nodes is equal to n minus L minus 1. And angular nodes is equal to planar nodes is equal to L. So L is equal to 2, therefore angular nodes will be 2 and 3 minus 2 minus 1, therefore it will be 0. So radial nodes are 0 and angular nodes you have to find out. Oh, sorry, angular nodes will be 2. So 0 comma 2, that is first option. Okay. And very interesting question, very tricky question, but I am explaining with the short trick. Understood? So radius of third orbit of lithium 2 plus is x centimeter. Okay, radius. So first of all, you should know the formula of the radius. R is equal to 0.0529 or 0.059 into n square upon z. Understood? So for the first let us take about the lithium. Lithium third orbit. Therefore, n value will be 3 and z value will be what? Z value for lithium. Very good. Z value for lithium is 3. Okay. So it is x centimeter. And you know that third orbit means 3 or third orbit means 3 wavelengths. Okay. So 3 wavelengths and third orbit. Therefore, that will be 9. From where 9 we got it? I think it is understood. Because third orbit will contain 3 waves. That means 3 wavelengths. So 3 wavelengths and it is atomic number also 3. So 3 atomic number, 3 waves. Therefore it will be 9. Okay. Because here first orbit question is about the first orbit. Understood? So 2 pi x upon 9 because number of orbitals also, number of orbit number is decreasing. So that will also include, and third orbit is coming to the first orbit. Therefore, it will be 2 pi x by 9. Okay. So these are the few questions. Now let's move on to the next part. Okay. So let's see the next part. Okay. Next part here it is about this 54 question already we have discussed. Next part I am telling you. Okay, next part pH of zero point 0.2 molarity NaHCO3. Okay, 0.2 molarity NaHCO3 solution. First, let me explain, then I will tell you the solution. NaHCO3. NaHCO3 at 25 degrees Celsius, what is given? 9.2. pH is 9.2 NaHCO3. It is one of the good thing. It can act as an acid because of the H plus. It can act as a base because it can accept H plus also to become H2CO3. Okay. So a 22 ml 2 molarity solution H2CO3 treated with 80 ml 0.5 NaOH results into formation of H2CO3 and NaHCO3. Actually, H2CO3 is a dibasic acid. So it can change into partial base. Okay. And with buffer with the pH of 8.6. Buffer with the pH of 8.6. Hence pKa2 of H2CO3 you have to find out. Here what with the pH you can find out pKa1, and by using the pKa1 as a mixture in the second step. Okay. In the second step you can find out pKa2. Let's see how it is. Okay, here H2HCO3 minus, it is an amphiprotic salt. So amphiprotic, actually it will be irrespective of the concentration. pH is equal to pKa1 plus pKa2 by 2. Okay. So here already given as pH is equal to how much it is given as 9.2. 9.2, half of pKa1 plus pKa2. But pH of the buffer, here main question is here only. pH of the buffer is equal to, pH is given as how much? 8.6. Okay. pKa1 we don't know. And log of salt, here it is given 22 into zero point 0.2. Sorry, 22 into 2, it will be 44 ml of acid is there. Okay. And 80 into 0.5, 40 ml of base is there. So what is extra here? Acid. How much extra? 4. And 40 mm will be converted into salt. 4 will be the acid. Okay. So we know the pH of buffer. We know the pH of concentration of salt and acid. By that we will come to know pKa1. So when you put here pKa1, you will get pKa2 as a 10.8. How much you will get? pKa2 as a 10.8. Is it understood? Now let's see the next question. So before proceeding question, I think it is better to take screenshot of this. Okay. Now let's go for the next question. Okay, here is the next question. It is the part of the double titration. And in double titration, I clearly mentioned, if you have not gone through, go through that double titration lecture. Okay, phenolphthalein. Actually, phenolphthalein can work only half neutralization, first equivalence point of the Na2CO3. Na2CO3 when titrated, when reacted with HCl, only one hydrogen will replace the sodium. Till that time only phenolphthalein works. Okay, here it is milli equivalent of NaOH is equal to millimoles. But here Na2CO3 it is not like that. Half will be only, because half of the sodium is only replaced. Okay, so when you use the phenolphthalein, these two reactions only will takes place. But methyl orange is not like that. It will work in the both steps. See here, both sodium carbonate Na2CO3, in this both Na are replaced. Okay, so are replaced here. Therefore, that is the difference between the extra Na2CO, extra HCl, whatever it is consumed here. It is just because of the second reaction. Here only half reaction is taking place. Here second reaction is taking place. So in this second reaction, we will use that for this purpose. Okay. See here, it is 30 ml of 0.1 when it is used methyl orange, 25 ml of 0.1 when it is used phenolphthalein. So that extra will be equal to the milli equivalent of sodium carbonate. You will find the change only because of these two reactions. Okay. So 2 into 30 minus 0.25. Here it is 30, here it is 25. Extra is used because of the Na2CO3 into 0.1. 0.1 molarity HCl, 0.1 molarity HCl. So that is equal to 1 milli equivalent. But here Na2CO3 equivalent factor is 2. Therefore, it will be 1 by 2 millimoles. So millimoles of Na2CO3. Here question is about the molar ratio. So moles of the Na2CO3 will be half mole. But in NaOH it is not a problem. NaOH it is not a problem. Here that extra 25 and here that 30. What is the difference between these two? That is 5 ml. 25 minus 5 into molarity is 0.1. Therefore it will be, how much it will be? 20 into 0.1, 2. And in case of the NaOH, its equivalent factor is 1. So this is also moles also. Okay. Now we have to find out ratio of NaOH. Okay. NaOH, how much it is? Sorry, here NaOH oblique Na2CO3. NaOH is 2 moles, Na2CO3 is half mole. Therefore, ratio will be 4:1. So, answer is second option. Okay. Now, let's see the next question. So, before proceeding, take a screenshot of this and we will proceed the next part. Okay, so let's see the next part. In the next question, 1 out of the 1 million Ag plus are replaced by the cation of the metal chloride MCl3. What is the number of cation vacancies formed when 1 mole of AgCl? Okay, so that means here oxidation number is how much? Plus 3. Oxidation number is how much? Plus 3. So 1 metal plus 3 and 1 Ag plus. Okay, so I will explain through the diagram, then it will be clear. So let us take plus, minus, plus, minus, plus, and minus, plus, plus, sorry, here it is minus, plus and minus. So when these three, here it is eliminated, here it is eliminated, here it is eliminated. Okay, so I am eliminating it practically. See, 1, sorry, 2 and 3. So here vacancy, here vacancy, here it is negative. Okay, here it is vacancy. 1, 2, 3 vacancies are there. But in one of the place, M plus 3 will be occupying. So what are the vacancies? Here vacancy, here vacancy. So 1 M plus 3 will provide the 2 vacancies. Is it clear through the diagram? So how many are there? 1 mole. So 1 mole into 2. That means 6.02 into 2. Then it will be 12.04. Okay. How much? 12.04. Is it understood? And percentage. It is of the percentage. Okay. So 12.04 into 10 to the power of 17. 1 million. 1 million means 10 to the power of 6. That means 10 to the power of 6 will be replaced with 1. Okay. So out of the 10 to the power of 6 vacant silver plus, and one place is occupied by the metal 3 plus. So 10 to the power of 23 into 10 to the power of minus 6. Million means 10 to the power of minus 6. Okay, 1 out of the 10 to the power of 6. That's why this 10 to the power of 17 came. Because of the million 10 to the power of 17, and because of 1 m plus 3 is occupying one position, 2 vacants. So answer will be second option. Okay. I think all of you noted this. Take a screenshot. Let's move on to the next question. Okay. So here next question is this graphical question. Let's read out. Okay. So here what does it says? In a reaction 2A gives B plus C. Okay. Follows the path shown in diagram. Okay. This is the fall. It is a first order reaction. Very, very important. This one, first order reaction. After 50 minutes will be the percentage of A converted into the products. Okay. So here after 15 minutes, see here, after 15 minutes, both concentration is same. Okay. Concentration of A reduced and concentration of B and C formed. Both are same. This is what you have to take it into granted. Understood? Now with this, you find out K value. Then after finding out the K value, you will get the first order equation. Then T value you will substitute, A value you will substitute, and then percentage only. So you can take A as 100. Okay. Converted into product, that will be X. X you have to find out. Okay. So let me tell you the complete procedure. Okay, here it is half lifetime. T half is equal to 15 minutes. Okay. T half is equal to 15 minutes. Already we know 0.693 by K is equal to T half. T half is equal to what? 0.693. So we can say K is equal to 0.693 by T half. So 0.693 divided by T half is 15 minutes. Okay, so you can solve what is the answer. 0.693 by 15. Okay, here T half is equal to 15 minutes. So after substituting here, T half is equal to 0.693 by K. So K is equal to 0.693 by T half, 0.693 by 15. That is equal to 0.0462. Okay. So now you can put in the first order reaction formula. So K is equal to 2.303 by 50 into log 100 upon 100 minus X. Okay. How much percentage of A converted into product? So here if you cross multiply, K is 0.0462 into 50 divided by 2.3. So you will get 1. So 1 means it is 10. So that means 10% of A converted into 10% of A converted into products. Okay. Next, let us see the question from the electrochemistry. I think you have taken screenshot. Okay, now let's see the next question. Temperature coefficient of EMF dE by dt. That means with respect to when temperature is changed by 1 degree, this much voltage is changed. That is what called as a temperature coefficient. Then enthalpy of cell is, that means delta H you have to find out. Okay, dE by dt is given and you have to find out delta H. Okay, so for that direct formula I will tell you delta H is equal to N into F. Actually it will be NFE cell, understood? But T into dE by dt. This is uh, dE by dt, temperature coefficient of the cell minus E. Okay, minus E, EMF. This is the direct formula for delta H. So here in this reaction, N value is given as how much? 2. So N value will be 2 and F value is how much? 96500. Okay, and temperature is how much? 293 Kelvin. Temperature is given as 293 Kelvin and it is given as minus 4.02 into 10 to the power of minus 4. Minus E cell is given as 1.015. 1.015. The main thing is you should remember this formula. Enthalpy change when temperature coefficient is given. After simplification, you will get minus 218.63 kilojoules. Here it is in the kilojoules. Okay. So you can cross check this answer on your own process I have told you. Okay. So again take screenshot for this solution. Then let's move on to the next question. Okay. Next question. Here it is. The molar conductance of NH4OH. Calculate pH of solution. So BaOH, okay, BaOH whole twice BaCl to NH4Cl are given. So simply molar conductance, that is inverted VMC is given. How much it is? Uh, Concentration is 0.5 and it is 2.5 into 10 to the power of minus 5. Now by using all these three, what are those three? Barium hydroxide, barium chloride and ammonium chloride. We will find out the molar conductivity at infinite dilution. At infinite dilution, that will be simply NH4Cl value. Okay, NH4Cl value. Okay, because we want NH4, you will get it from the first equation. And for OH, where you will get BaOH. But here two BaOH are there. Therefore, half of BaOH value. Okay, but we don't want barium here, we don't want chlorine here. So therefore, minus half of BaCl2. Okay. So if you calculate by substituting these values, Molar conductivity at infinite dilution, it will be 2.525, 2.525 into 10 to the power of minus 2. This is the molar conductivity infinite dilution. Now degree of dissociation, molar conductivity at the given concentration, molar conductivity at the infinite dilution. Okay. See here 2.5 and 2.5 almost it is same. So degree of dissociation will be approximately 0.099. Understood? So now what is the concentration of OH minus? Simply C alpha. Okay, C alpha. Alpha is already given. C is given as concentration 0.5. So 0.5 into alpha 0.099. Okay. On simplifying into you will get 0.495. But I think that is what we want. Sorry, this is OH negative. Then you will get POH, then you will find out the pH. Okay. So answer will be according to calculation. Okay. Calculation, after calculation, it will be 12.695. I am getting 12.695. You yourself also can try. Okay. This is concentration. When you apply negative log, you will get POH. When you apply 14 minus POH, then you will get the pH. Okay. So take a screenshot, then we will go for the next question. Then which of the following solutions will have pH close to 1? Close to 1 means very, very strong acid. So here if you see 100 moles and 1 by 10. So exactly this pH will be 7. Okay. Acid should be left over. Here 55 upon 10, 5.5 and 4.5. So it can be, but let us see the strongest part. So this is 1 and this is 9. Here base is more. So pH will be greater than 7. 75 by this will be 5. Okay, and see here more acid is left over. Among the second and fourth, more acid is left over. So more chances, and answer will be 4. This is how with the tricks you can solve the many question directly. Then equilibrium constant for this reaction, delta H and delta S is given. So first of all, by using them, what you will find out? Very good. You will find out the delta G naught. Okay, delta G naught is equal to delta H minus T delta S. Okay, here temperature is how much? 298 Kelvin. And most of the students, what they are making mistake is 10 joules. Here S is in the joules. Okay, and delta H is in the kilojoules. Okay. So here kilojoule must be converted into joules, then substitute. Okay. Then you will get delta G naught. Now delta G naught is equal to minus NF, minus NF only. Otherwise, you can write it as a direct equilibrium constant. What you can write? Equilibrium constant, you can write it is equal to minus 2.303 RT log Kc. Okay. So here to avoid the calculation, already he made 2.303 into RT. So you can substitute directly 5.5705. So from here you will get delta G value, from here you will get delta RT, then you can find out the anti-log of that. Okay. So answer will be 10 to the power of 10. See for any calculation mistakes if I have made, you can correct me. Okay. Take screenshot. Let's move on to the next page. Okay, next page is here. 60 grams of acetic acid, 46 grams of ethyl alcohol react in 5 liter of flask to form acetate. That is, ester is formed. On taking 120 grams and 46 grams, the amount of COH formed. Very simple, you will convert into moles, and 60 grams is the molecular mass. So this is 1 mole and this is also 1 mole in 5 liter. Okay. So let us write the equation, then automatically you will get the Kc. Okay. So once you get the Kc, you substitute the other reactants. Okay. So then you will get the equilibrium value. Is that clear? So CH3COOH. Okay. Plus C2H5OH. Values are confusing but very fascinating. CH3COO, C2H5 plus H2O. Okay. Initially this is 2 mole. Sorry. This is 1 mole. 60 by 60. How much mole? 1 mole and 1 mole. Okay. And 5 liter. So 44 grams. That time 0. Okay. Then after that 1 minus x. This will be 1 minus x. Here x. X divided by 5 and 1 minus x divided by 5. 1 minus x divided by 5. Okay. So here actually Ac value, okay, here 44, if you calculate its molecular mass, it will be 88. How much it will be? 88, because it will be 106. 106 minus 18. Okay, so this is water moles, so it will be 88. So 88 means half mole only. Okay, how many? 44 grams are there. That means half mole consumed, half mole consumed, half mole formed. Okay, so once you know the equilibrium constant, what will be the equilibrium constant? Kc is equal to, okay, here water also considered half mole. Understood? Because same value will be there, half mole. So what is the answer? Kc is equal to simply half by half by half by half. So 1 by 2 acetate and 1 by 2 water, 1 by 2 carboxylic acid, 1 by 2 alcohol. Therefore Kc is equal to 1. So once you know the Kc, what you will do? You will use it for the second reaction. What is the second reaction will be same, but only thing we will change the values. We will change the what? Values. Okay. So CH3COO C2H5. So this will be 2, this will be 2 plus H2O. Okay. X and X. So here initially it will be 0 and 0. 2 minus x, 2 minus x, x and x. Once you put here, you will get the x value. Okay. So I think you can solve by simplifying. You will get how much you know. It will be 58.66. I am getting how much? 58.66. Take a screenshot. Taken. Let's move on to the next question. NaHC2O4, KHC2O4 required equal volumes of 0.2 normal and NaOH separately. See here, it is a redox titration as well as acid-base titration. When I use KMNO4, it will convert C2O4 into the CO2. Okay, whereas NaOH will neutralize this hydrogen and this hydrogen. Okay, then what is the molar ratio of NaHC2O4 and KHC2O4 and H2C2O4? Okay, in the mixture. Is that clear? Okay, here actually spare mistake is there, question typing mistake. It is KHC2O4 dot H2C2O4. This is a total mixture. Okay. So when I use KMNO4, this will be oxidized to CO2. So equivalent factor will be how much? 2. Here also 2. Here also 2. So for this mixture equivalent factor will be 4. So 0.2 normality into, let us take volume as a V. So then for NaHC2O4 it will be 2A. For mixture of KHC2O4 and H2C2O4 it will be 4B. So here that is the way. Next NaOH when I am neutralizing, I should look only for the hydrogens. In the NaHCO3 only 1 mole hydrogen is there. NaHC2O4, sorry. Okay. In the mixture KHC2O4 1 hydrogen, H2C2O4 2 hydrogen. So 3B. So two equations are there. When you take the ratio, you will get the two values. Okay. And ratio only we want. So after simplifying, I am getting 3:1. I think you will also get 3:1. This equation making is very important. Okay. Now let's see the next question. Okay, next question is initially flask A contained oxygen at 27 degrees Celsius. Okay, and 950 mm of Hg. B contained neon gas. Again, it is also at 27 degrees Celsius, but 900. Okay, two flasks are allowed by removing this. Okay, allowed to mix. So final pressure in the combined was 910. Okay. If volume of B measured to be 10 liter present, then mass of the oxygen present initially in the flask A. Okay. So volume of the flask B is measured. Understood? And you have to find out mass of the oxygen presently in A initially. That is at 27 degrees and 250. 27 degrees and 250. Okay. So very simple question it is if you solve it in the technical way. Combined system, it is how much? 910. Okay. So 910 is the total volume. Okay. So this will be, let us take this as a VA. Okay. This as a VB, volume of base. Understood? So 950 mm P1 V1. Okay. 950 into VA, and here 900 plus it is 900 into VB. Okay, divided by VA plus VB. VA, this is the total volume. Okay, so actually V total into P total is equal to PA into VA plus PB into VB. Understood? But already it is known that by simplifying this, you will get VB. By simplifying our ratio, you can find out VB by VA. You will get 4. Okay. So VB is equal to 4 VA. So VA, what is given to us? Flask of B. Okay. This is given as 10. Therefore, it will be 2.5 liter. So in this 2.5 liter, everything we got it. Pressure we got it, volume we got it, temperature we got it. Okay. So by substituting PV is equal to nRT, you will come to know the moles, and by using the moles, you will come to know the mass. Okay. I have simplified. I got 4 grams. You may get something else. You can try. Okay. Now let's see the next question. Next page. Okay. Then Van der Waal parameter. It is a theory but tricky question. Van der Waal parameters are given, A is given and B is given. Okay, significance. Considering the value of parameter which is correct. Okay. So here critical pressure depends on, critical temperature depends on the intermolecular force of attraction. Okay. So here gas A 6.5, gas B 18. So higher the critical temperature, higher will be the ease of liquefaction. Therefore, to the higher temperature, it can be stored in the gaseous state. Therefore, C answer is correct. Okay. So note down with the reason. Then let's move on to the next page. Next slide. Okay. Then 10 moles of ideal gas, 10 moles of ideal gas heated to constant pressure of 180 m from 27 degrees to 127 degrees. Okay, from 27 to how much? 127. So that means 100 degrees Celsius it is increased. If CV is equal to 21.686 into 10 to the power of minus 3, what is the delta H for this process? Okay, so let's see the Cp, what is the formula? Cp is equal to Cv plus R. So it is already given as 21.686 plus 8.314. Okay, what is this? 21.686. So CV already we can substitute here. R value is how much? 8.314. Understood? So into 10 to the power of plus 10 to the power of minus 3 t. Okay. So by comparing this equation, CV plus R. Okay. So only R I have added. This is what CV given as. Understood? So by simplifying, you will get this as a, when you add this, you will get a fancy number of 30. 30 plus 10 to the power of minus t. But already we know the Cp is equal to delta H. Okay. Delta H is equal to 10 mole. This is for 1 mole. Okay. 10 into 30 into 100. Okay. From where we got 100, that will come to know, plus 10 to the power of minus 3. Okay. And 27 degrees Celsius. So 27 degrees Celsius, 10 to the power of minus 3 by 2 into 400 to 300. Okay. T2 minus T1. 400 whole square minus 300 whole square. Okay. So on simplifying, you will get the complete delta H value. So I got 30350. I got how much? 30350. Now CSBR has a edge length of 3 root 3 parameter. Shortest interionic distance between cation and anion. Okay. So cation and anion, that means body diagonal only root 3a. Body diagonal. So body diagonal by 2, you will get the interionic distance. This is the body diagonal, this is the corner. So up to here we want total distance will be root 3a. So edge length A value given as a 3 root 3. Then on substituting and simplifying, half will be root 3a by 2. Okay. So that is the shortest distance. So root 3 into root 3 into root 3 into 3 divided by 2. That means 9 by 2. That means 4.5 picometer. So this is the answer for the 68th question. Now let us see the next question. Okay, next packing efficiency. Okay, packing efficiency of a two-dimensional. See here it is a two-dimensional. That's why what we have to do, we have to take the area into consideration. Okay, first of all, number of atoms. Here you can find total, it is divided into 3 identical parts. So 6 into 1 by 3. Here 1 by 3, here 1 by 3, 1 by 3, 1 by 3, 1 by 3, 1 by 3. 6 into 1 by 3, and here it is complete. Therefore, number of lattice point per unit cell will be 3. And area of atom, here we are not taking volume because it is two-dimensional. So 3 into pi r square. Okay. So this is the area occupied. This is the empty space. This we are not counting. We are counting only the occupied space. So actually area available, area of a hexagon is equal to 6 into root 3 by 4, 2r square. It is 2r square. Okay. So divide both of them into 100 if you do. This is the area occupied, this is the area available. Then you will get 90.7% occupied. Okay. Then very interesting and very good question. Half-lives of two radioactive elements for alpha and beta decay. If it is alpha decay, 4 years. If it is beta decay, parallel reaction, this is 12 years. Okay. Then percentage of element that remains after 12 years. So first of all, let us take the average T half. That will be 4 into 12 divided by 4 plus 12. That means average, because of the alpha and because of the beta, it will be 3 years. So we got 12 years. Percentage we want answer. After first 3 years, 50%. Second 3 years, 25%. Third year, 3 years, then 12.5. Like that up to 12. 3 plus 3, 6 plus 3, 9 plus 3, 12. So after 12 years, what is left over? 6.25. That's why we are taken as 100. So 6.25% is the answer. Okay. Take a screenshot. Taken. Now let's see the next question. Next question, if 1 mole of van der Waal gas B is equal to 0. So that means in this formula we can use B is equal to 0. Temperature PV versus 1 by V plot is shown below. So whenever this you compare with the y is equal to mx plus c. Okay. So P plus A upon V square. Actually here B will be there. Okay. But B is equal to 0. V minus NB. So B is 0. Let it be any moles that will be 0 is equal to RT. Now multiplying this inside PV A by V is equal to RT. Now I wanted to convert into y is equal to mx plus c. That's why I am taking it here. So minus a by b plus rt. So here x is equal to 1 by v. So slope will be is equal to minus a. So slope is equal to, see what is this, 21.6 minus 20.1 minus 3.3 minus 2, that is equal to 1.5. Slope is equal to how much? 1.5 we are getting. Okay. Good question. Combination of the mathematics and states of matter. Okay. So let's see the next question. Take a screenshot. Then let's do the next question. Okay, next question here. Actually, there is a diagrammatic mistake. The diagram it is not properly drawn, but I am considering it is properly drawn. Okay, concept I will tell you. There is dotted line and solid line. This is the solid line. This is the dotted line. So dotted line work is WD, solid line work is WS. And what is the difference? It is carried out reversibly, but it is carried out irreversibly in step 1, step 2, step 3. 3 steps it is carried out, and we wanted to find out ratio of the dotted line divided by solid line. Okay, so simple, very very simple. P delta V, P delta V, P delta V. So total work you will get, and this is isothermal process, reversible process. Therefore, we can use this formula. Okay. So here final volume is how much? 5.5. Initial volume is how much? V2 by V1. So 1 by 2. Okay. Then you will get 4.8 liter atmosphere. So if you divide both of them, I am getting 1.80. Okay. Mainly this graph study pressure is 4. Okay. And volume it is supposed to be actually 3 by 2. It is supposed to be here, but some misalignment is there by computer operator. So kindly adjust with that. Okay. Next. So let us see the next question then. Taken screenshot. I will take a screenshot. Okay, now let us go for the next question. Okay. Okay, here what is the ratio between Mg2 plus and aluminum 3 plus in 1 liter vessel? Okay. So 1 liter vessel saturated solution of MgOH whole twice. See here OH negative here also there, OH negative here also there. So you have to make the approximation, proper approximation. Understood? So this is a simultaneous solubility question. MgOH whole twice will give you Mg2 plus plus 2OH minus. Let us take solubility of MgOH whole twice is X. So this will be 2X from this side. Aluminium hydroxide solubility Y. So this will be Y and this will be 3Y. But it is present together, therefore this 2x is written here, 3y written here together. Okay. Now if you compare here, it is 10 to the power of minus 12, it is 10 to the power of minus 33. We can say that this is much more soluble than aluminum hydroxide. So that means OH negative given by given by magnesium is very high when compared to this one. Therefore, I am neglecting 3y word and 2x will be available. Okay. So KSP of MgOH whole twice is equal to this one, and KSP of ALOH whole thrice is equal to this one. Okay. So substituting and simplifying, you will get x by y. Okay. So we want x by y both are divided, then I am getting 8. So mainly if you are able to write this equation and neglect 3y, not 2x, why not? I think already I have explained. Okay. So take a screenshot, then I am clearing, and let's move on to the next question, next page. Okay. So here we are about to close down, so be attentive. Now it is given as a first order kinetics. A 4A reversible B plus 2C. Okay. So here according to this equation, initially total pressure. So whatever the initially, that will be just because of the A only. Okay. So 4A gives B plus 2C. Therefore it is 800. 0, 0. Now after 10 minutes, total it is found 650. So if I take 800 minus 4x, this will be x. Here it is 1. And it will be 2x because it is 2c is there. So total pressure will be 800 minus 4x plus x plus 3x. Therefore, it will be 800 minus x. But it is given as 650. Therefore, x is equal to how much? 150. X is equal to 150. So, 150 into 4. Then it will be 600. 800 minus 600, that is equal to 200. See here, initially 800 was there. Now it is 200 is there. So, that means it is 2 half-lives. 10 minutes is a 2 half-life, then 1 half-life will be 5 minutes. So answer will be 5. What is the answer? 5 minutes will be the answer. Okay. Then next, cesium atoms, largest naturally occurring atoms, not interested. 2.62 radius. Okay. 2.26. Therefore, edge length will be 2.6 diameter, sorry. Okay. Diameter will be 5.2 angstroms. Okay. Now total molecules of cesium laid side by side in the 2.5 centimeter. Okay. This is the total C point 2.5 centimeter. Like this, if I am laying down, so we have to take the diameter, not radius. Okay. So here 1, 2, 3, 4 like that, total distance divided by 1 diameter, you will get the number of atoms. Total distance is 2.5, number of each diameter is this one, you will get number of atoms. But question is moles, question is about the moles, so I am dividing with the Avogadro number. I will get x value. Okay, is that clear? X value is 7.97 as per my calculation, but it is you can take as a round figure, you can take it as a 8. Okay, so this is about the paper discussion, complete DPP discussion of the physical chemistry. Now, if you are able to do on your own once again, then you will be master in physical state. Okay, sorry, physical chemistry. I hope you all will be waiting for my next paper on the physical chemistry, which will be some more efficient. Okay, see you. Bye bye. Happy studying, and don't forget to visit which can regularly. Okay.